We'll now move to the time period of 1940 to 1950, which is considered the birth of computers. World War II introduced a new set of problems, and as a result, there were several military research projects where the goal was to build automatic computing machines to solve these different types of problems. We're talking about things like troop deployment, talking about secret codes, communications between different nations, but it's just trying to come up with these automated machines to help out during the war. One of the first projects was done in 1931, prior to the US entering the war. And this was done by the US Navy and IBM. They funded a project at Harvard, and this was led by Howard Aiken, and the idea was to build a computer which was known as the Mark I. This was the first computing device to use the base 2 binary numbering system. So, I mean, as you should know now, most machines use binary numbers. We'll talk more about this in details later, but this is the first device that actually uses the binary numbering system. Now, the memory capacity of this system was 72 numbers, and it can perform 23-digit multiplication. Nowadays, you might not think that's much, but that is a huge advancement compared to some of the things that were around beforehand. I mean, think about things like the difference machine, for example. I mean, this is a huge step from this. And this project was completed in 1944. So yes, it took a very long time to finish this project, but they eventually did get it done. And this machine was actually used for the next 15 years. Around the same time, a more powerful machine was being developed. In 1943, the Army and University of Pennsylvania funded a project, and this was led by J. Presper Eckert and John Mauchly to design what was called the ENIAC. Okay, well, what's the ENIAC? Well, it's the acronym for the Electronic Numerical Integrator and Calculator. And this was actually completed in 1946, and it was the first fully electronic general purpose programmable computer. So let me make this clear. Beforehand, the machines were using mechanisms. It was using machines, little gears and wheels and so forth. But this is the first one that was fully electronic. And this was able to perform so many different types of calculations. It was quite a huge device. It was about 100 feet long, 10 feet high. It weighed about 30 tons, if that gives you an idea of how big this machine was. And because it was fully electronic, it didn't have any of the slow mechanical components that were found in other machines, such as the Mark I. The Mark I was a mechanical computer, where the ENIAC was an electronic computer, so it didn't have all those additional pieces. While the Mark I and ENIAC were two very well-known examples of early computers, they definitely weren't the only ones being designed during this time period. So in between 1939 and 1942, John Atanasoff and Clifford Berry were designing their own computer at Iowa State University. This was called the Atanasoff-Berry computer, or yes, it was known as the ABC. Now this computer was only used to solve systems of linear equations. It wasn't really used for much else beyond that, but it was one of the first ones that handled linear equations. In 1943, Alan Turing, who was one of the main guys in computer science, he designed the Colossus computer. And what's really interesting about this particular computer is it was used to crack the famous German Enigma code. And the reason why this was significant was the Nazis believed that this code was unbreakable. So we kind of showed them that, yeah, we can't break it. So the Colossus computer did take care of that for us. And then around the same time, Germany was trying to work on its own version of the ENIAC computer, and this was called the Z1. However, this was not finished before the end of World War II. Although the machines that we just described, the ABC, the Mark I, ENIAC, Colossus, Z1, although all those were computers in the fullest sense of that term, they weren't really anything like the modern computers that we use today. They were much larger. They used like vacuum tubes and wires and all this. I mean, there are wires sort of in our modern machines, but this was very different. I mean, these were much larger machines, more mechanically oriented. Even the ENIAC had mechanical components, even though it was the first electronic computer, but they were like these huge components. They still weren't anywhere close to the design of the computers that we use today. There was an additional step that needed to take place. And this was done by a guy by the name of John von Neumann. And he was one of the most instrumental people when it came to creating the computer that we know today. So who is this guy? Von Neumann, he was one of the most brilliant mathematicians who ever worked on the ENIAC project. Like, genius does not even begin to describe this guy. He's very, very intelligent. In 1946, he came up with a completely different computer design. And this was based on a model they called the stored program computer. And before then, all the computers were programmed externally. They were using wires, connectors, and plug boards. The memory unit stored only data, and it didn't store instructions. So that was the big difference. It stored data, but it didn't store instructions. And so for each of these problems, so every time there was a new problem introduced, we had to rewire the entire machine in order to solve that particular problem. So just imagine for a minute if your computer had to be rewired whenever you wanted to solve a different problem. So that was very tedious. So what von Neumann did is he came up with this model that would resolve some of those issues. So for instance, instructions would be encoded as binary values, and they would be stored internally instead of using external wires. And what this did was, if we needed to make any changes to those instructions, well, we no longer need to rewire the system. We don't need to change those wires. Instead, we just need to rewire the instructions. We just need to change the instructions that's stored internally in the system. So this was a huge, huge advancement that allowed us to transition to the computers that we use today. The model of computing that was proposed by von Neumann included many of the important features that we find in today's computer systems. In fact, in order to honor von Neumann, what they did is they named this model the von Neumann architecture. And we will be looking at this in more detail later on in the course. But many researchers took this model and used it to design more machines. So von Neumann's group actually developed the ISYS in 1951, and this was one of the first stored program computers. It wasn't the only one. There was another one built around the same time called the ISYS at Cambridge University, and this was led by Professor Maurice Wilkes. Now, these machines, they were much slower and bulkier and less powerful than our current machines, but the way that they executed programs is very, very similar to the way our computers are being run now. Now, the first commercial model of the ISYS, which was called the UNIVAC 1, was developed and sold on March 31st, 1951. And this particular model used the ISYS model for its computer, but this was the first commercial computer. And what's important about this particular date is that it marked the true beginning of what we call the computer age.